In grade 10, we were introduced to trigonometry and specifically focused on right-angled triangles. This year, we're going to expand that into triangles that do not necessarily contain a right angle, but we need to remember some of the skills we previously learned. So trigonometry is literally the measurement of triangles. We need to know how to label a triangle. Just recall that we use capital letters to represent the angles, and we use lowercase letters to represent the side lengths. The side is always the lowercase letter of the angle directly opposite from it. So if this is angle B, imagine like a bow and arrow. You pull back the arrow and you shoot through that side across from it. That is lowercase b. If this is angle A, and again, imagine a bow and arrow, you pull back, you shoot through the side across from it, that's lowercase a. And if this is angle C, you pull back and you shoot through the side opposite from it, which is lowercase c. This is a right angle triangle because we have this little square here that indicates that's a 90-degree angle. This second triangle here is not a right angle triangle, but we still label the sides the same way. If this is angle D, the side opposite from it is lowercase d. If this is angle F, the side opposite from it is lowercase f. And if this is angle E, the side opposite from it is lowercase e. This right triangle has a hypotenuse. Now, we're used to seeing a squared plus b squared equals c squared. That is Pythagorean theorem. However, we know c does not necessarily have to be the letter used to represent the hypotenuse. This is my hypotenuse. It is the longest side of my right angle triangle. It's also directly across from my 90-degree angle. We already have two strategies that we can use to find missing side lengths in a right angle triangle, or the missing angle measures. The first one is Pythagorean theorem, and just remember we can only do this if we have a right triangle. We know a squared plus b squared equals c squared is the relationship among those sides, and this is the value of the hypotenuse, that longest side. We also have three primary trigonometric ratios, which again can only be used with right angle triangles. We have sine, cosine, and tangent. For any right angle triangle with a given angle, if I take the side opposite from that angle and divide it by the hypotenuse of that triangle, I will always get the same ratio, no matter how big or small that triangle is. If I take the cosine of that angle, I divide the adjacent side from that angle by the hypotenuse of that triangle, I'm always going to get the same ratio. The way that we remember which sides relate to which ratio is SOHCAHTOA. If you can't spell this, it's difficult to remember which side goes with which ratio. So the other thing you can do is picture a farm. So here's my little farm, here's my barn, here's my old horse. And then you can remember some old horses can always help the other animals, and it indicates which side lengths go with which ratio. Also remember that this is our reference angle. The hypotenuse is always the longest side in the triangle. The opposite and adjacent sides will switch depending on the angle that we're using to refer to. If I start with this angle, this is my side opposite. Adjacent means beside. So these are the two arms of the angle that make up that angle here. It cannot be the hypotenuse. The hypotenuse is set. So it's the side that's not the hypotenuse that is beside that angle is my adjacent side. And again, when you enter these into your calculator, just remember you have to be in degree mode in order to get the correct values. Take a look at a couple examples here. Each of these contain a right angle and a reference angle. Now, obviously, we know the sum of the angles in a triangle is 180 degrees, so we are able to calculate this angle as well. But as much as possible, you want to go with the original information given. The first thing we're going to do is identify from this reference angle, what are the two sides that we have? This, remember, is my opposite, so I'm just going to write that in here. This is the hypotenuse of the triangle. We're going to go back up here. It is a good idea to write that on the top of your paper. And we're going to say, okay, opposite and hypotenuse, that goes with the sine ratio. So when we go to set this up, we're going to say the sine of 27 degrees is equal to the side opposite divided by the hypotenuse of that triangle. This creates a proportion. And so we have 1 as the denominator. when we go to solve a proportion, we're going to cross multiply. So remember, we're going to multiply the two sides opposite from each other, and we're going to divide by that one. Okay, so I'm going to get you to grab your calculator and do this along with me. First thing we're going to do is make sure we're in degree mode. So we're going to go into the mode, and you can see degrees is right here. We want that black box on it. So we're going to go down to radians, we're going to go over to degrees, and we're going to press enter. And then we can go second function quit to get out of there. All right, so when I go to put this in, I'm going to start with the sine, and you'll notice that bracket pops up. We're going to type in our 27-degree angle, and we have to remember to close the bracket, and then we're going to multiply by 25. Now, I would then divide by 1, but dividing by 1 doesn't change my value. In the directions, we were told that unless it otherwise specifies, we will round side lengths to the nearest tenth. So this is in the 10th position. Take a look at the number that comes after, and because it's a 4, that one stays as 11.3. So again, keeping our equal signs lined up, we're going to have x is equal to 11.3, and then take a look at the units, and we can see that this triangle is in meters. So we're also going to indicate that that is in meters as well. Okay, so that's our first answer. Now we're going to scroll down here to the second one, and we're going to say, all right, from this reference angle, I know this is my side opposite. This is the adjacent side, because again, this is my hypotenuse. Adjacent is the arm that makes up that angle that is not the hypotenuse. Go back to your little some old horses can always help the other animals, and we can see the trigonometric ratio that relates the opposite side to the adjacent side is tangent. So we're going to set up the tangent of that angle is equal to the side opposite divided by the side adjacent. And again, remember, this is over 1. So when you put this in your calculator, we multiply the two values that are diagonal from each other. 15 times 1 is 15, and then we divide it by that other value. So when we go to type this into the calculator this time, I'm going to clear this out, and we're going to go 15, and now we're dividing that by the tangent of 63. And you don't need to close the bracket because that's the last value we enter, but we can do that anyway. Okay, to the nearest tenth, because this is a side length, 6 is in the 10th position. Take a look at the number that comes after. Because it's a 4, it's not going to bump that up. So again, keeping this lined up, I'm going to have x is equal to 7.4. Nope, sorry, 7.6. And then take a look at your units. And again, this triangle, we're working in meters. So that is going to be my answer for the second one. All right, I'm going to get you to pause me. And there are 2 remaining questions here. I want you to try to do those ones. See if you can set up your ratio, enter it into your calculator, get the correct value. And once you do that, come back and we'll see how you did. So I'm going to trust that you did that. And when we take a look at this one, we've got our ratio set up. We entered it into the calculator. In terms of the rounding, this is the value we get when we enter this 8 divided by the cosine of 48. Because we're rounding the side lengths to the nearest tenth, this is in the 10th position, but this is a 5. If the number that follows is a 5 or higher, that bumps this up 1, so that bumps it to a 10, which bumps that to a 2. So we want to have 12.0. We want that value in the 10th position for that one. And then when you get to the last one, we're now looking for the measure of a missing angle. So you're going to recall we set up the ratio the same way. So this is the angle we're looking for, but we are relating the adjacent side to the hypotenuse. So I know I'm using my cosine ratio. And again, this is how we want to set it up. When I go to put this into the calculator, recall from last year, anytime we're looking for the angle, we take the inverse of that angle. So we're now going to go second function cosine. That puts that little -1 exponent in there. And then when I enter it, I go 4 divided by 5. And again, you can close the bracket here. We're going to press equal or that enter sign. And that gives us the value of the angle. Because I'm rounding my angles to the nearest whole, unless it specifies otherwise, this is an 8. Which bumps that up to a 7. So 37 degrees is the measure of that angle. To conclude, we're going to take a look at how to solve a problem that involves more than one right angle triangle. In my first example, I've got 2 right angle triangles together. And remember, if we're going to use either Pythagorean theorem or a primary trigonometric ratio, besides that 90-degree angle, we need 2 other additional pieces of information. In the first example, we are ultimately trying to determine the length of side W. So we're trying to find this measure. But if we look at this triangle, I only have one piece of information, that side length of 3. These are unknowns, and I don't have any angles other than my 90-degree angle. So I'm not going to be able to start here. I'm going to have to use my other triangle to get some information first of all. And we can see that if we can solve for y, that will give me the 2 pieces of information I need to be able to calculate that value. Because I don't know any angle measures, I'm going to have to go back to Pythagoras' theorem. So in this triangle, this is my hypotenuse. If you need to go back and do this the long way, so a squared plus b squared equals c squared, in this case we can see that 4 has to go in the place of that c. It doesn't matter which value we put in for a or b, so we're going to be looking for one of those sides. If I'm looking for, let's say, a, we subtract that side over here to isolate a. So that's why I'm subtracting here. And again, if you need to go through and write the steps out, go for it. But when I put this into my calculator, we're going to get an irrational number. You cannot round this until the end. So that number stays in your calculator. Do not round it until the end. If you round too soon, it is going to impact the final answer. All right, so when we take a look at that, so I've got this value stored in here, and then we're going to go again. I have to use Pythagoras' theorem because I don't have any angles. So now this is my hypotenuse. That is my c squared that I'm looking for. It doesn't matter the order in which we add these. So I know this one side has that value plus the other side has that value. So I'm going to set this up. Now this is already in my calculator. So when we go to enter this in, we're going to go second function, and then square root. Oh, not like that. We're going to go second function, square root. And then do you see how we have answer on top of that negative key? So we're going to go second function, answer. And that's going to take this entire value and store it into the calculator. And then we're going to square that. And we're going to add it to 3 squared. And that will give us the value that we're looking for. And then we're rounding this to the nearest 10th. Again, that is a 7, which bumps the 10th position to a 3. And in this particular example, we're not given any units, so I just left the side length as 4.3 units. Next example, we are looking for side length B. So this is side length B. Take a look at the triangle that contains B. Do we have 2 pieces of information plus that 90-degree angle? Well, I know this angle here, but that's only one piece of information. So I first need to find another value. I've got a second triangle attached to it. So I can use this triangle to get this side length, which is connects both of them, and that will allow me to get those 2 pieces of information in which we can solve for B. Okay, so starting with this one, this is again a right angle triangle. This is my reference angle of 48 degrees. Now, it's really important that you label your triangles, label all of your information. From this triangle, I can see that this is side length C. I didn't use a C because lowercase c and capital C look so much alike. I decided to go with this one. So I also have this is the opposite to side length D. Try not to just stick X and Y in here. Go with the letters that you're given based on that triangle. So I put a lowercase d in there, and again, you could have gone with C. That's why it's really crucial that you label everything. From that 48-degree reference angle, this is my opposite side, this is my adjacent side. So we can write that in here. This is the opposite, and this is the adjacent, and we know that is tangent that relates those 2 sides. So I set up the tangent of 48 is the opposite side divided by the adjacent. I put that in my calculator, and I got that value. Now we're going to go again. So from this D, and now I'm going to actually just clear out those last 2, because depending on which reference angle we're using, it changes which side is which. So I'm going to take those out now, and I'm going to say, okay, from the reference angle I have in this triangle, I'm looking for the opposite side. So I'm trying to figure out what that is. And this is now the hypotenuse of my ABD triangle. We know the ratio that relates the opposite side to the hypotenuse is sine. So I set up my sine ratio. This is the opposite. This is my hypotenuse. The value that we calculated here, we write down here. And again, we need the whole value. So that's stored in our calculator. So when we type this in, we're going to go sine of 51. Again, remember to close the bracket. Oh, don't do that. Okay, we're going to go sine of 51 remember to close the bracket, and then we're going to multiply, and again, you're going to go second function, and then press the negative button. That's going to, because the answer's on top, that's going to plunk that whole number in there. You're going to press enter, and that gives you the value of b, which we then round to the nearest tenth. My last example has two different office buildings, and we can always assume anytime we have a building that they're built according to code and go up at a 90-degree angle. We know that's not true. The Leaning Tower of Pisa is a prime example, but we will make that assumption. We are ultimately looking for the height of the building on the left. So that's this side here that I'm trying to calculate. I already know the building on the right is 42 meters tall. So because we're assuming that everything is built according to code, this is a 90-degree angle here, which makes that 90 degrees from the horizontal. So I'm going to put in my 42 meters there as well. We know if we can determine the length from here to here, by adding those two measures together, we will get the height of that building. I don't have enough information in my top triangle to solve for that. I know the reference angle, but that's it. I need two pieces of information besides the 90 degrees. So I'm going to utilize this triangle on the bottom and say, okay, if I can calculate this distance between the two buildings, that will allow me to then use that measure to solve ultimately for x. So I'm going to start down here and say, okay, this is the reference angle I'm given. I know this is 42 meters. It's the same height as this is. So from this angle, this is our opposite side. This is our adjacent side. We know that's the tangent ratio. So we're going to set up the tangent of that angle is the opposite side divided by the adjacent side. And again, you're going to put in your calculator. We know 1 times 42 is 42. So we're going to go 42 divided by the tangent of 38. And we're going to get that number, which we will not round off until the end. Keep that in your calculator. We're going to go again now. So the triangle on the top, my reference angle is 52 degrees. I'm looking for the side opposite. I now know the side adjacent. So again, that's the tangent ratio. We're looking for the opposite. We know the adjacent side. It comes from that number there that we just calculated. Because you have this in your calculator, you can just multiply that number by the tangent of 52, and we're going to get the value there. Now, the reason I did use an x here is because I don't have any other variables on this diagram. I don't have a or b or c, so I can choose any variable. Whatever you choose, just make sure you label it, so whoever's looking at your work knows where that number is coming from. This is the measure of x. I'm adding to it the 42 degrees, and that's going to give me the height of the building, which when we round to the nearest tenth comes out to be 110.8 meters.